Welcome to the third video in this series of learning C# programming. In this video we're going to talk about classes, objects, and inheritance. We're going to create a player class, an enemy class, and a boss character class, and show how these classes can interact and represent the entities that we want in our game. In this case we have a player and an enemy and a boss character. So first what we're going to do, from where we were leaving off before, where we discussed while and if loops, we're going to right click on our RPG game project, and we're going to add a new class, which is on the bottom. You can say new item and then select class, but it's a shortcut here for class. So we're going to name this class player. It's a good practice to have every single class that you have in C# be a separate file. So you can see here the program class, which you can see is denoted by class program, is inside its program class, and now we're going to have player being its own player class. So here we have the player class, which is right here. As I mentioned in a couple of videos before, it's always good practice to comment your code, and it's going to be helpful if you comment your code, because then you can help other people if you're working in a team, or you can help remind yourself what certain items do. And to kind of show an example of that, I'll show that later, but in this case, you know how you comment a code with the 2 backslashes and then you can type and stuff? Well, in this case I'm going to type in 3 backslashes, and then it automatically comes out with it's called like a comment tab, I think, or something of that nature, where you can type in, it writes out like summary, etc., and I can write what this class is and it'll work with our autocomplete. So here I'm going to say this class represents the playable character. Represents, it looks a little weird. Alright, so we have our class player, which this syntax was automatically created when we created a new player class. However, I would like to point out that to make a class, you say the class, you name the class, and then you put parentheses. And then what's inside the parentheses is what's defined inside the class. Now if we want this class to be accessible outside of this namespace, RPG game, we'd put public. So other code pieces in different namespaces can access this class. If we make it private, then this class is only available to a namespace. But by default it's private by not typing anything in, and that was erroring in saying that by classes by default you leave it, you don't specifically declare it as private. Right in this case I want the public class, I want the class player to be public, because I want other code to be able to access our player. Now once you're here, you have the ability to add properties inside the player to determine what he has. So in this case these properties can be either public or private, like I mentioned before. So if I make a public class, a public property, and I want it to be an integer, and I want it to be his health, I can do that. Now in this case we need to have the ability to get the health, the player's health, and if we get the player's health, we have to return the health. I'm kind of showing this a little complicated, and then I'm going to like cheat a little here, but you have to create a private variable to hold the health. Then the public variable is what can be used to get the health, and what that's going to return is the private variable. And then when you set, you're going to be setting the private variable to the value. So this is what a property looks like. For every single time you want to get the player's health, or you can create a new property, this is what you have to type in. Now this is kind of like boilerplate code is what people call it. We always have to type in, like, oh, I always have to type in the same thing, and it's always the same unless I want to do something crazy. So in this case there's actually a neat little trick you can do to avoid typing all this, because who wants to remember this? This is too hard. So if we're going to erase all that, and we're going to type in prop for a property, and then we're going to hit tab, and then basically what this is going to do, you can hit tab to switch between the two areas here. So I want to make an int, and I want this to be my health. Now with this squiggly here, by just saying get inside here and then set, it automatically creates the getter and the setter the exact way I wrote it, but you don't have to see it, you don't have to type it, you don't have to know about it. I created health, and now I don't have to worry about anything else with it working. I can easily just create, like, let's say mana, if I want its mana there, but we're not gonna worry about that right now. We're just worrying about the player's health. So now we have a player class, which when created, he has the health. He has health. Now, as I mentioned before, for autocomplete purposes and for good practice, you would want to document when health is. So I'm going to put the three comments here because a property can be labeled specially. I'm going to say this represents the player's health values. Okay. Now, when a class is created, it has to be instantiated. So a class, there can be one player, or there can be multiple players. And if you have one definition of what a player can be, but you can make 2 or 3 or 4 or 5. So what that's called is instantiating. When you instantiate a class, you make it so you create a copy of that class in its own single person. He lives by itself. So if I instantiated David, now David exists as a player. Instantiate John, now John exists as a player. So at this point, I want to demonstrate making the player. So in our main program here that we have, at the very beginning, before I even type in a name, I'm going to create the player character. So create the player character. In this case, I'm going to type in player. Now, as before, I mentioned that I was going to show that here when you type in player, as you can see in the autocomplete menu, we have this class, which is donated by this symbol here. This class represents a playable character. This text right there is the text I wrote right here. So now if you wanted to put something else that somebody, when they put their mouse over it, like it actually has text here that can help people and help you remember what it is. If you didn't put that there, like I'm just gonna delete this real fast. It just says player, and you're like, what's a player? So it's always good to document your code. And then again, here I'll show for the health when that comes out. But here I named player, which is capital player is the class, but I'm gonna name this variable that stores player as lowercase. So it is case sensitive. You can't have the player be called player as capital P, but player can be lowercase player. And then when you instantiate a new class, you have to use the word new because you're creating a copy of it in memory. So new player, and then parentheses, parentheses, there we go. So basically, we're going to store into this variable player a new instantiated class of type player, and then construct it which is what parentheses means. You're running the constructor on here, like you're creating a new class to store in the player object here. Now, what exactly does this part do? What does it mean when you're calling the constructor to run the class? Well, if we go over here and we create a constructor, the constructor is a function that has the same name as the class. You can see this is player with the parentheses. Like you recognize here is what you see here. And then what the code that runs in here gets run when you create a new class. Now, by default, nothing happens. It creates a new class and nothing happens. So this right here does nothing. So if I don't say it in here, it automatically exists and does nothing. That's why this code is not erroring, because it exists and does nothing. But I want it to do something in my case, so I'm going to make the constructor and I'm going to make it do something inside of it. Now, as you saw what I did earlier, I know that if I type in CTOR, which stands for the code snippet for constructor, if I hit tab twice, it writes it for me. You're going to find there's a lot of things in C# that if you don't have to like memorize everything. Like I know like sometimes in school they'll be like, hey, you can't use your calculator or something like that, or you have to memorize this and write it all by hand. When you get into the real world with good IDEs, which is what Visual Studio is, the code will kind of write itself for you. You just have to know the concepts. I want to make a constructor. How do I make a constructor? I don't remember. I just type in CTOR and then boom, it wrote it for me. Like, I mean, it's good to know it, but you don't have to like, it gets to a point where you're not necessarily thinking like, what do I have to type? You're just thinking about what do I want to do, and then you do it, which is nice, which is why I'm a big fan of C# and Visual Studio in general. But anyway, I'm going to put some comments here saying that this is the default constructor, and basically what I want to do here is set the health value to 100. So here I'm going to set health to 100. So basically when I create a new player, it's going to call the constructor, and in the constructor I'm automatically setting his health to 100 because I want our player to have 100 health right from the start. Because when you create a int variable, the default value is 0. So because it's not specified, health equals 0, and we don't want him to be dead right when we start. So health equals 100. So the player has health and equals 100. And then we're just going to give him one more property here, and that's going to be a string property. I can't type string. And it's going to be name. The name of the player. So right now the player has two properties. A player has health and he has a name. I'm not going to set the name here because I don't know what the name is, so I'm not going to make a name come up every single time. I mean, I could make it be like unknown name or something, so by default he has a name, but in this case I'm not going to bother. So in program here, we're going to now use those items. So here I created a playable character and stored it as player. So as before, you saw I said what is your name, and I stored it inside player's name. I'm not going to store it inside a local variable to this main function player's name. I'm going to store it inside the player. So basically I'm going to take player, I'm going to hit dot next to him. So classes, if you hit dot after the variable that has the class, it'll give you the properties and functions that are available to this class. So in this case, based off of these wrench, I guess, the thing represents a property. So we have two properties, health and name. In this case, I'm taking name and I'm making the player's name equal console readline. And as I mentioned before, if you put your mouse over it, the name of the player, that's what I had as the function title. So autocomplete works for you here, which is very nice because, like I said, you want the IDE to work for you. So now we stored the player name. So now every place that has player's name before is going to error because I just removed it. Player's name does now not exist. So I'm going to copy this with Control C, and I'm going to replace it with player name, and then the code now works exactly the same, except now player's name isn't stored inside the player class. Now alternatively, what we could do here is instead of creating the player character this way, we could create the player character after the name here. And I'm going to say create the player character and store his name. And in which case I'm going to do print the squiggly lines and then squiggly brackets, and then in here we're saying that after you create a player, set the initial values past the constructor. So the constructor runs and health is set to 100, but after that set the values here to whatever you want it to be. So if I hit Control space, which does autocomplete, so I'm hitting Control on my keyboard and then space, it brings up the autocomplete of the options I have to choose. I'm going to choose name, and I'm going to set it to console.readline. So this is if you want to like be you don't put semicolons inside there. This is if you want to be fancy and do it like a one line, and over time this is kind of the better way to do it, depending on where code works. But there is literally no negative to doing it the first way I showed or this way. They both work, and they both take the same amount of processing power and etc. It's not going to affect things. But I'm gonna just leave it like this because I typed it. So the rest of the code is going to work. So now we got the player's name and we got the player's health. So what we're going to do now is we're going to right-click RPG game, and I'm going to add another class, and we're going to call this enemy. Now what this class is going to be, it's going to represent the base elements of an enemy. So here I'm going to be stating what properties an enemy has in this game. So in this game, the enemy also is going to have health. Oops, prop, tab, and he has health. And I mean, an enemy can also have I guess a name as well. Right now he seems pretty similar to the player character, but I can't really, at the moment I can't really think of anything else to give an enemy. But I'm going to, then the same thing as before, I'm going to create a constructor, call it the default constructor, and set the enemies. I don't really know how to spell that. We're just going to ignore that spelling part. But we're going to go health equals 100. So the enemy's health is 100. So now we got an enemy and any setup. Now I'm going to right click here. I'm going to create a new class as well. And we're going to call this guy boss. And he's boss because he's the boss enemy. He's the boss. He's the bad guy. You have to fight him afterwards. So we got a class boss. Represents the boss enemy in the game. So here, what does a boss have? Well, as we know, a boss has health, and the boss has a name. Just so you know, here, string is technically a class, so it has a capital S, and it shows up in green. But because string is so used in the language, Visual Studio kind of made it like a default data type in the lowercase form. Both of them are valid. You can say lowercase string or capital string. No other class is like that except string, and I prefer to write string as in capital, but that's kind of like an old school thing because I learned it back when it was capital. I'm erasing it to write it in lowercase so you guys can see that, but just so you know, either way works. Like, you know, out of habit, I type it like this. Not like that, but I type it like this. But you guys, whatever way you guys decide to do for string, it's good. The only thing you want to make sure is that if you're working in a team, that you find out what your group is writing and you all write it the same. You don't want, let's say, David to write it in capital S and then John to write it in lowercase s. Then you just ruin the code base. It becomes unreadable. It's unmaintainable. It's gross. Ugh. Okay. So boss here has health and a name. In this particular case, I'm just duplicating code. What makes the boss different from the enemy? Right now, he has health and a name. He's the exact same thing. A boss is like an enemy. Like you can use the word is. Like a boss is an enemy. The boss is not a player, but the boss is an enemy. So the boss has everything an enemy has, but he might have more. Another example is kind of like cars can have tires. If you have a tire class, a tire can't be a car, but a car has tires, and a tire doesn't really have a car. I mean, it depends on how you word it, but a car has tires. So a tire can't be a car, but a car can have tires. And when you get into cases like this, you can use inheritance. And now to represent inheritance, we got public class boss. You put after here a colon. I did too much. A colon, and then you can type in the other class name. So here we're saying boss inherits everything from enemy. So this turns yellow, I mean green, and it says hides an inherited member enemy health. So now that means that the enemy, everything the enemy has, the boss already has. So he already has health and a name. So I don't need to specify this. Because a boss is an enemy, he already has health and a name. And because a boss is an enemy, when an enemy is created, it's going to give the boss 100 health. In this case, he's the boss. I don't want him to have 100 health. So in here, I'm going to make another constructor and call this the default constructor. And I'm going, by specifying a constructor here, I overwrite the default constructor of the enemy. So by default, enemy would have ran. And I'm saying overwrite this and don't set his health to be 100. Set the health to be a higher value. So here the health is 150 because he's a boss, like a boss. All right. Also, because I'm defining these characters in here, I'm going to name them here. So set up boss name, boss. I don't know how to spell boss, all badass. Bass name. Boss. Okay. So name. And we're gonna go Metal Gear fashion here, and this is Big Boss. So Big Boss is the name of the boss, and the enemy in this case, I don't really want to specify enemy because he's a base class, because then that would imply that boss's name is as enemy. For the enemy's name, we're gonna do things a little different. The enemy class should not really have names set in the constructor, because if the enemy is the base class, if this is an enemy, the boss is an enemy, blah blah blah, they all have different names. If I put the bosses here as like evil chicken or something of that nature, then every enemy, even the boss, is going to be evil chicken from the start. So we want to make it so the enemy's name is set by the caller, so the program, but I want to force it to be given at the start, because you might forget to give a name and then that's not good. So if I want to force a value, I can put it inside the constructor, the ability to input that value. So in this case, I'm going to say that I want you to input the string name into the enemy here, and then use that. So now I'm going to set the enemy name. So capital name equals lowercase name, which was passed in. This name that is passed in is now set to the name that's in the property of my class. And by doing this, I'm forcing you, when you create the enemy, to give me a name, and then I store that name, and that's the name now of my enemy to be used. Now this part here, the default constructor, I added a parameter here. So if I delete all this, I could either add it in manually, but I like to delete it all and hit the 3 backslashes, and you'll see it makes a parameter for the name. So if I put back the default constructor, and here I say the name we want to give to this enemy, I can specify what parameter I want to the value, what the parameter is supposed to be. Like name is supposed to be the enemy's name. So I can say that there. So now we can see that by doing this, we have an error in the bottom. So if we go over here to the boss, you'll see boss, the enemy constructor is forcing you to put in a name, and I am not doing that here. In which case, I don't have to set it up here with name. I can get rid of this, and I'm going to specify after this constructor, I want to say that the base class, which in this case is enemy, you run his base constructor, which you'll see when I type in this parentheses, it'll tell you the base constructor of enemy is name, and here name, the name we want to give to the enemy. This is the part that I wrote inside the comment. So we're going to give the name Big Boss. So in that case, now that we have made these classes, Okay, and also right here, is first enemy dead? We're just gonna say is dead. So we're gonna go to the enemy here, and we're gonna say enemies have a property boolean is dead, and then we say like determines if this enemy is dead. The name of the enemy, the health value of the enemy. All right, and then just because I prefer to have spaces here, I put that. So now here, instead of creating a variable like is enemy dead, by default it's false. Booleans by default are false. So here I'm going to create a variable to track the first enemy. So I'm going to create an enemy. I'm going to call him, it's an enemy. It's a giant enemy crab. So it's a giant enemy crab. Gamers, you know this, right? Old gamers. Okay, boomer, right? So giant enemy crab. So we create the new enemy class, and then we end it. But as I said before, I want to force the name. You just can't create an enemy like this. You have to give me a name. So if I put my mouse over here, it says you have to give name inside the parentheses. So here you can see that if I type in the first parentheses, it autocomplete comes up and says, hey, what do you want to add? The name we want to give for the enemy. So that's the part I type. So we have to give a name, and we're going to call this giant enemy crab. And that's the enemy crab's name. Enemy crab here has 100 health as well. Okay, so here it's player.name. You have encountered an, I'm going to say A here, and instead of saying enemy, I'm going to end this, and I'm going to append it as to the string before the giant enemy crab dot name. So whatever we change the name, we don't have to remember to change it here, but whatever we change the name here will automatically go here. So we're going to say you have encountered a giant enemy crab. What would you like to do? So actually, we should name this first enemy, because that would make more sense in the fact that it can be changed. It doesn't have to be a giant enemy crab. Because right now, first enemy, if I do it that way, I can say this is giant enemy bat, and it will work here, and it will make sense English-wise on the name. But we're going to keep it crab, because I want a giant enemy crab. What would you like to do? So we tell, we say what you want to do. And here, we're saying while the first enemy is not dead, repeat the playable cycle. So now we're saying while the first enemy is dead, is it dead? If it's not dead, we continue. So we're continuing. So now we have literally right now have not changed the code at all, but we have made it have classes now. So now we have a playable class, a player class that has health, and an enemy class who also has health. And a boss. We haven't got to the boss fight yet. Like, phew, Okay, so here, I'm just going to change the console right line here a little bit. You have encountered a giant enemy crab. What would you like to do? I'm going to take this part. Oops. And then I'm just going to write that out inside the while loop, because it's going to make more sense to put it out each time. It just makes it easier for you to be like, oh, what are my options every single time? So write out to the screen your options. Okay, so that's there. Okay, so now we're saying, like, what would you like to do? You read the player's action. This is what he does: 1, 2, 3, or 4. So in this case, we're going to handle slot number 1 now to start. You chose to single attack the giant enemy crab, we're going to say. So you chose to single attack and then I'm going to end this here, and bring it here, and then it's out here, first enemy, dot name. So you chose to attack there. Now what we're going to do is create a random int that we're going to use to attack. So when you create a random number generator, the random number generator has to be a variable that exists, because random isn't true random, so you have to be able to generate the random numbers from a variable. But basically what that means is I'm going to create a random class, which is a class that already exists through the .NET framework and .NET Core framework. And we're going to call it random equals new random. And basically we created a random class. Create and store the random class. So now we go down here, we can say apply the attack damage to the enemy. Now how do we want to do this? We can do this two ways. Both are valid, one's good, one's bad. It's it's bad coding practices. You might not necessarily want to do it that way, but the kind of bad way is to say like the enemy or the first enemy dot health equals the first enemy health. So set the first enemy's health to what the first enemy's health existed minus random dot next, which gets you your next random number here. So now we're going to minus his health by a random number. So one issue with this right now is that random.next does any random integer. It could be 1, you did 1 attack damage, or it could be 8,632, in which case you did a critical attack and hurt him bad, but we don't necessarily want to do that. So here, next, as you can see, has 2 overloads. So you can either call it like this with no parameters, or if I hit the down arrow right here, or down on my keyboard, or up, you can see that I can give the max value, which returns a non-negative random integer that is less than the specified maximum, or we can go to a min value and a max value. So in this case, I want to say you can attack either between 1 and upper bound. Let's say 1 and 15. So you can attack. You can either hit him for 1 damage or it could be 15 damage. The issue with this though is that now the program here is in control of handling the enemy's health. What you should have is each class should be capable or handling its certain function. In this case, program should be handling the program, which in this case is to handle the RPG game. The program doesn't need to know how to take health away from the enemy. The enemy should know how to take away health from himself. Like what happens when the enemy gets hit, because that's just the enemy needs to deal with that. The program doesn't care if the enemy got hit. It's like working about what it's doing. So in this case, the enemy class, we're going to make a function. So this function is public because we want to be able to call it outside of the class, and we're going to return nothing from this class, which will return later something. But right now, this class is going. This function is going to return nothing. We got to give it a function name. Let's say gets hit, and then inside the parentheses, squiggly squiggly, we're going to say what we want to pass into this function, and we're going to pass in a hit value. So we're going to do the code here, and we're going to say this gets called when the enemy is hit, and the hit value is the amount of damage the enemy should take, or enemy will take. It's not should. He will take this damage. Okay, so here we're going to say here, like, subtract the hit value from the health. So here we're going to take my health of my enemy, and it's going to equal my health of my enemy minus the hit value. And then we're going to do an if statement here, just because we want to see that check if the enemy is dead. So if health is less than or equal to 0, the enemy is dead. The enemy is dead. So now we're going to make another function, and then just to kind of show that this function I'm going to make private. Private void die. And then we're going to say called when the enemy is supposed to die. So now what this is going to do is write to the console that the enemy is dead. So here I'm going to say that the enemy name has died. And then here we need to call it. So if the health is less than 0, we need to call the function die. So now basically that means when you get hit, you pass in the hit value. It's like, hey, I hit you for 30 points. I minus 30 points from my health. Now, is my health now less than 0? If so, then run the die function. Otherwise, don't, and you skip by and you don't run die. And then if you run die, it's going to write out to the console that this person has died. And then it's going to set the Boolean that this enemy has died. So now is dead equals true. So now when you die, it says that you died, and you are now dead. Now I'll show in a second here. Public means that you can call get hit from any other class, but private means you can only call this function inside of the enemy class. So enemy, like inside all this code here, I can call this function die, which you saw I used die inside of this gets hit, but I can't call it outside. So what that means is, like here inside program, we have this first enemy right here. And if I say first enemy dot gets hit, you see here the function gets hit, I can say gets hit, but do you see die in this list at all? I don't have the ability to do die. Die doesn't exist. I can check if he's dead, but I don't have die. So if I type in die, you can see down here, you can't really, I'm blocking it. Oh wait, it says right here. Enemy die is inaccessible due to its protection level. So that's because the protection level is private. If I was to set this to public, then this code works now. However, I could just tell him to die. And why do I get to decide that he dies? He should only die when the enemy runs out of health, like what the enemy decided. So this sort of thing is based off of what you're programming. Like, it's not always, right or wrong answer. Technically, you could put public, and as long as your programmers don't mess it up, it's right. But this way, you're kind of restricting yourself. You're saying, like, I should never be able to tell this guy to die. He should only die when his health goes less than 0 because he got hit. He can only die if he gets hit and his health goes less than 0. So here we're saying that for the player's attack, where we hit him for the first one, we're going to do it this a little differently. We're going to say dot gets hit, and then we're going to put those in parentheses. So we're saying when the enemy gets hit, pass in an integer, which this is getting a random integer between 1 through 15 inside here. So the enemy is going to get hit between 1 and 15 on this. Okay. And then it's going to it should probably write out that he got hit. Write out that the enemy got hit. So I'm going to say was hit for damage. So we're going to write out giant enemy crab was hit for 6 damage or whatever. So in this case, we did our single attack, and then we're hitting the enemy. Then after this enemy hit goes, we're going to go down, we're going to skip all these things, and then loop back up and ask to continue. So in this case, this is going to happen until the enemy dies, because once he dies in the get hits function, the first enemy is dead will then change to true. So is this enemy not dead? No, he is dead. So then we leave the while loop. So at this point, option 2, 3, 4 does nothing. But if you attack, you'll attack him between 1 through 15 damage, and it'll keep going. I can keep attacking until he dies, and then the program will end. So now if I run this, we can see that. So what's your name? Warrior David. So I'm going to attack with 1. It says you chose to single attack the giant enemy crab. Giant enemy crab was hit for 11 damage. Ooh, that's good. That's better than 10. What would you like to do? Well, again, I'm going to do 2 just to mess with you guys. So you chose to 3-strike attack, but right now it's not doing anything. So I'm just going to single attack. So I hit for 7 damage, 6 damage. I should probably write out how much health he has left. It's probably good. Yeah, let's do that before we continue. So we're going to go here to the enemy. Was hit for blah, blah, blah damage. He now has health remaining. So, oops. This is Warrior David. Warrior David has encountered a giant enemy crab. So I'm going to attack. So it's a giant enemy crab was hit for 13 damage. He now, I put no, spelling mistake. He no has 87 remaining. So as you can see, I'm attacking him, he's going down. And this one should kill him. Oh, unless he's lucky and gets only 4. So he's 2 damage, so if we attack him for 1, okay, boom. So that he now has -9 health remaining. So the giant enemy crab has died and the game is over. And I have won. He now has that. Okay, so that ends this video's lesson on classes and how class functions and properties can be used to, and inheritance, to show how classes can be used to specify certain objects and be like, this is a player, this is an enemy, this is a boss is an enemy, and then you can kind of combine its features together, and then in the code you have simple, like, written English out words like, oh, this enemy gets hit, and then you can have it do certain things of that nature. Join me in the next video to learn about for loops when we do the multi-attack and build the enemy attack cycle back, where we're going to defend and be able to run away, and switch statements where we rewrite the if statements here to handle switching a little better. See you then.